Your fetch has been deployed subsea for some time and been collecting lots of valuable data. But how do you get that data back to shore simply and efficiently? Let's get to it. Fetch has an integrated modem for easy remote data harvesting, either from a crewed or uncrewed vessel or a remote or autonomous vehicle. This is done by communicating with the fetch using a transceiver. We'll set this up using our Subsea Array Manager, SAM, software. Connect your transceiver to your PC or laptop COM port in the same way you did to connect your i1 to your PC or laptop. Simply choose the appropriate COM port from the list after selecting comms from the main menu of the SAM software and click OK. And then select the Device tab and click the Test button to establish the connection with your transceiver. Note, you will have to set the correct baud rate for your transceiver. The acoustic comms or Acomms linked to the fetch can then be configured via the Link tab. Data harvesting will use this Acomms link, so it needs to be optimized for the fastest data rates to be used. When dealing with Acomms, it's good practice to think about how the placement and environment could affect the quality of your communications. So think about the placement and depth of your transceiver. Consider if there are any other sources of noises nearby which could interfere with your communications, and whether there are any other acoustic systems being used. This could be an echo sounder, for example. Make sure these are disabled before you start. In the SAM software, select the Advanced button on the main Link tab and click Get for transceiver and transponder. Here, you have the option to change power, gain, and telemetry scheme settings for both your fetch and topside transceiver. You will need to change these settings for the fetch once it's in the water if the power and gain were originally set for in-air use for testing and setup. Acoustic settings for typical use cases and available fetch power levels can be seen on screen now. A good feature to use to ensure your acoustic settings are optimal is the Acoustic Link Test in the Link tab. Any red warning lights in the traffic light display must be addressed using the Advanced page. When it comes to setting your telemetry scheme, start by using 900 bps. Using the fastest reliable speed for the transponder uplink will reduce harvesting time and preserve battery life. Once power, gain, and telemetry scheme settings have been amended, make sure to click Set to send the changes to the fetch, and then test the acoustic link again, aiming to have all traffic lights in green. Once all lights are green, return to the Advanced tab and click Update Job so the software stores the revised parameters in the job file. With your acoustic comms link optimized, you're ready to start data harvesting. We don't need to stop the instrument from logging. The fetch can deliver recorded data to the transceiver at the same time as running its measuring program. A handy tip when data harvesting is to use bookmarks. To do this, on the Retrieve tab, select Get Bookmarks. This indexes the last page of data in the instrument and also the last data page that has already been retrieved. The current logging page will also be reported. From and to can be modified to request missing pages to infill data gaps. Alternatively, start and stop date time fields can be used. Now all we have to do is to click the Retrieve button. The data will be transferred from the fetch and pages of binary records will be stored as .dat files on your PC. Traffic lights indicate acoustic link status, and if you do run into problems when harvesting your data due to a lost link, there are a number of things to consider and try. The lost link could be due to drifting out of the acoustic beam, so move your vessel. The environmental noise level near the transceiver may be too high, so lower your transceiver further if possible. There could be other sources of noise, so reposition away from a noise source. Try reducing the Acomms baud rate or changing the power or gain. Check if other acoustic systems are running that could be affecting your acoustic link. Now that you've retrieved your data, you can export your files for assessment and visualization. Click Export in the Retrieve tab. If you want to automatically generate plots for each sensor, tick the Visualize Data option before export. Selecting the Export button will export CSV files with subdirectories created for each UID. Note, these files are read-only. If opening your CSV files in Excel, be aware of automated date formatting. Date stamps are in the format day, month, year, but regional Excel settings can cause these to be converted, causing issues when interpreting your data. The format of the CSV file contents is described in the file spec document 8318-FS. Use the zip raw data button to create a backup of raw data files. There are a number of things you can do using the Acomms link as well as data harvesting. 2 other important tasks you can set the Acomms link to are 1. Tracking your fetch to the bottom or surface, and 2. Setting the AZA to work once it has reached the seafloor. To track your fetch, click the Track button in the Link tab. When a fetch AZA is on the seabed, you will need to enter deployment limits. Go to the AZA tab and click Advanced to do this. Enter the max deployment depth, for example 3,000, 6,000 or 7,000 meters, and click Set Deployment Limits, and then close. Note, the max deployment depth is limited by the rating of the sensor. To test the fetch on the bottom and set the AZA mechanism to work, there are 3 key steps. First, get AZA status to check pressure readings. Second, start AZA logging. And third, retrieve at least 1 AZA logged record before leaving site. If you have any questions or would like to know more about fetch, please check out our website or get in touch via sonodyne.com or your local Sonodyne office. Don't forget to like this video and subscribe to our YouTube channel to keep up to date with everything new from Sonodyne. Thanks for watching.